so we're going to learn route inspection. Right, route inspection is sometimes called Chinese postman because it's about how a postman can deliver all the mail as quickly as, well, with the least walking necessary. And he starts from the post office and has to obviously walk on every single road to deliver to every single house, and then goes back to the post office. And he's trying to do that with the least amount of walking.
Yeah.
And that's what we're trying to do. Okay. So, there we go. So this is an example of a town, lots of houses on lots of roads. So, if I give you the pen, if we say the post office is at A, so it's got to start at A, is that working?
Yeah.
Can you just sort of start walking round and see if you can get round all of the roads?
Okay.
Don't worry too much about the order, just sort of wander around.
And I don't want to repeat, do I?
No, because you've already delivered on that road.
Okay.
So can you just pause 1 second F? Can you see A? A is where the post office is, yeah?
Yeah.
So there is now a road, this road here,
Yeah.
and that is the road that's going to get us back to the post office. You don't want to go down that road unless every other road is done,
Right.
because otherwise you're at the post office and you've done all the roads around the post office, yeah?
Okay.
So when you're doing it, you're kind of thinking, right, so
I've made it. I can't do it now. I've made it closer. I didn't know I had to get back to A.
Yeah, you've got to get back to the post
I've got
office.
to get back to
Why can't you do it now?
A. Because I'm thinking I've made a closed circuit because I've got a triangle here and I've got a triangle here. So if I went down there.
Yeah, and then went round the triangle.
But then
I see.
So
if you go back down this one now,
then I
then you're
can't
stuck at
help
G.
but repeat.
Yeah.
So it's very
Okay.
difficult. Then I have to go back and think of another
Right.
time.
Okay. Why isn't that? Oh, there we go. Okay. Right. So where did that?
So just start again. Or okay.
Was there anything else you can do from here?
I think right, I can go round there, round there, round there, round there.
Yep.
But then I'm back to my closed triangle. Because even if I went up there, up there, up there, I'm still got my closed triangle.
Yeah,
so
then
I've
you're stuck.
started probably.
Yeah.
No, I don't think this going round
Plan.
here was a good plan. No, I need
Okay.
to come up with a different plan.
Okay. If we focus in, G seems to be a bit of an issue, right? This is where you were getting stuck.
Hmm.
I don't know why that just happened. Right, if we focus in on G and see what's going on and why there's a problem occurring at G. This is being really slow, I don't know why. To react, but no, it's not. I think it's just the notebook is playing up. So G, right? Now, you came in towards G like this, yeah?
Yep.
And then you headed out, no, not that way. But anyway, say you headed out that way.
Yeah.
Right? Later, you need to come back to G along one of these roads because these houses need delivering to.
Yeah.
So we come down here, and then later we head off again, and then we need to come back. Now you can see that it doesn't matter which one I came in at, which one I go out at, which one I come in at, which one I go out at, because there's another in, I am going to get stuck there.
Yeah.
It is impossible not to get stuck there because I have to at some point go in towards it,
Yeah.
then I go off again, then I come in again, then I go out again.
Yeah.
Now if I have to come in again, if there's 1, 2, 3, 4, 5, which there is,
Yeah.
then I'm stuck because I've done all of them. If there's a 6, I'm alright, I go off again.
Yeah.
So the fact that there is 5 vertices, 5 edges coming out of this vertex means you are going to get stuck there.
And that would apply to any odd number, wouldn't it?
Yes. Are there any more vertices on here which are odd? They're called odd vertices if they've got an odd number coming out.
So D has an odd number as well.
Yeah.
And that looks
So you get stuck
towards
there.
G.
So you go in, out, but then you've got to come back in and you can't get out again.
Yeah.
Not without repeating something.
A's got even, B's got even, C's got an odd.
Yeah.
So that's 5 as
So
well.
that's in, out, in.
Yeah, and F is even, and H is even, so, and E is odd.
E is
That's
odd,
it.
yeah. So in, out, in. So it doesn't matter what you do, there are 4 vertices here at which you will get totally stuck.
Yeah.
It is impossible to traverse this network. Okay?
Is there a name for that? If it's
Non-Eulerian.
non-Eulerian.
Eulerian, from Euler. What? There. Euler
Yep.
looked at all these problems and solved them, basically. So Eulerian is the same as traversable, meaning the postman's fine. He can just start at the post office, walk around, only go on each road once, deliver all his letters, come back. Non-Eulerian is not that.
Okay.
Okay, so what we need to do, he is going to have to walk along roads he's already delivered on. He's going to have to.
Yep.
So the question is now, this is so slow, this rubber. Which roads should he walk along twice? Because he's going to have to walk along some of them twice.
Yes.
Now we know it's going to be something to do with D and G and E and C.
Yep.
Because they're the ones you get stuck at.
Yeah.
Now these are odd vertices. We can make them even by putting a repeat in here and a repeat in here.
Yeah.
So he's either, this one could be the 43 say.
Yeah.
And this one is the 39. So
Yeah.
that would be a way of making them even. So now he goes into G and out of G, into G and out of G, into G and out of G.
Yes.
And he continues his thing. Same thing here, in out, in out, in out, and same with the other two.
Mm-hmm.
So that would mean that he walks an extra 40, 50, 60, 70, something.
72.
70? Or
Oh, sorry,
82. 82. So he walks an extra 82
Yes.
miles, whatever. That's quite a long postal route if it's miles. But anyway, meters. So that's one possibility.
Yeah.
Now, you could traverse this. You could start at A, wander around, finish back at A. But that might not be the best route. So it might be better if we repeat something else. You know, we didn't necessarily have to do that. So
Yeah.
it's still got to involve those four, C, D, G, and E.
Yeah.
But maybe if we repeat that one and that one, for example, then he's doing an extra something.
When we
47
want to
plus
repeat
38.
the one with the smallest number next to it.
Well, we want to repeat the smallest total. It's not really relevant, you know, that one's really big and one's really small or whatever. It's the total, because he's got to walk this extra route and this extra. He's got to repeat that road and repeat this road.
Yeah.
So the total of all the repeats is what we want to be as small as possible.
Okay.
Okay? So once we've decided what the smallest total possible way of connecting these up is, he can repeat those ones, you add that onto the total route he's got to walk anyway, that's how far he's got to walk.
Okay.
Okay, so there's quite a structured way of doing this, which will appear in a minute. There we go. Okay, so this table is going to control everything.
Okay.
And then what we're going to do, and this is going to make sure we get all the marks in the exam, keeps everything tight. What is the smallest total? Which arcs are we going to repeat? What is the new total?
Okay.
So, first of all, we identify the odd nodes. We've
Right.
done that. They're the
Yeah.
odd nodes. Now, it might be best to pair up C with E and D with G.
Okay.
Or maybe C with G and D with E.
Yeah.
Or maybe C with D and G with E.
Okay.
Okay. Now, this is the bit where you have to concentrate,
Okay.
because what they do to make this difficult is that they make the shortest connection between C and E not necessarily direct. So you have to look quite carefully, because it might be that C to E is here,
Yeah.
but it could be that going dung 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 is actually less. So you have to have a look. It's not the direct route, it's the shortest route. So it might be that going via something else is actually shorter than going direct.
So if this was a really big pathway, could I combine, say, Dijkstra's with this to find
Well-
the shortest route between the repeats?
Dijkstra, yes, Dijkstra, if you wanted to do a Dijkstra starting at C
And we're trying to get to
and
E.
trying to get to E, yes, then Dijkstra
Yeah.
would find the shortest route, yeah, absolutely.
Cool.
But in this case, we're just going to look at it.
Yeah.
Okay, so C to E, shortest
Right,
route?
so C to E is shortest route's 39, because otherwise you've got this 31 and 34, or you've got 47, 35.
So,
Seems
so
like
that's
the-
direct, yeah?
Yeah,
39,
direct,
okay.
39.
C to G,
C to G, 39 plus 38 is
76?
77. Yeah. 77, and it looks like 47 and 43 that'll add up to more, and none of the others seem to be. I have got a 31 and 34 there though, so that's probably better. So that's 65.
Yeah.
So we go that way.
Or what about you looked at this 47, yeah?
Yeah.
And you didn't
Even consider that
notice
way.
that is 23 and 22, which is 45, which is less than 47. So it still means that to get to here, you still do more than go via F.
Yeah, yeah.
But you have to really look around and see.
Okay.
So what did we decide? C to
So
G?
31, yeah, C to F and
Right.
then to G.
So what we're going to do is going to make a note of that. So it's actually C, F, G.
Okay.
And that is a total of 65.
65, yeah.
Okay, what about C to D?
C to D, 47, or your 45 going on that left hand.
It's less, yeah? So we put here C, A, D,
Yeah.
45. Okay, D to G?
D to G, where's G? 43 or 51, or we can go 35 for 38. No, it looks to me like the direct
one?
43 is best.
43, okay, D to E?
D to E, 35, yeah.
35, direct.
Direct.
G to E?
G to E, again, direct, 38.
38, okay. So these are the things we could join up. We want the total to be as small as possible, so we add them up. Should we do it with a calculator?
Yeah.
They're quite big numbers.
Thank you. Okay, so what are we adding up the total?
39 and 43. How much extra would you have to walk if you paired them
82.
up? Okay.
65. Are we pairing everything?
Yeah, because if we pair C with G, going via F,
Yeah.
then we would also have to pair up D and E to make them even. So we would have to pair, in total, we'd have an extra of 65 and 35.
Okay, so that'd be 100. And the other one would be 83.
Okay.
So that's the smallest there.
So this is what we write in the exam. You make this table,
Yeah.
then you write the smallest is 82. Now what that means is that we're going to repeat. Come on, rubber. We're going to repeat CE and DG.
Yeah.
So we're going to repeat this road, and we're going to repeat this road.
DG.
The DG, the 43,
Yeah.
that one.
Yeah.
Yeah? So we're going to repeat DG and CE, and the new total will be the old total of all of the roads. Obviously, you would have to add them all up, plus the repeats, which come to a total of 82.
Should I add them up?
Nah,
No. Okay.
whatever it is. And then let's make it up. 530.
Okay.
Okay? And then it's meters or kilometres or miles or whatever it is, yeah?
Yeah.
And now,
Because you lose a mark, don't you, if I don't put meters?
absolutely, yeah,
Right, okay.
totally. Right, now, you should be able to do this really easily now. Start at A, at the post office,
Yeah.
and whip round delivering letters.
Okay.
Yeah, so A, B, F, H. Hang on one sec, 'cause we need to write these down. A, B,
Yeah.
where did you go next?
F,
H, G.
G.
Yeah,
And then go back D on the arc,
yeah.
and then back to A.
You need to take your pen off.
Right.
D, A, yeah.
Okay, then we go to B, and then, oh, and then I'm repeating them wrong. Right, okay.
B, C.
C.
B, C, yeah.
And then to F,
Yeah.
and then to G, and
Okay.
then I'm going to go to D.
G, D.
Yep.
Okay.
I'm written now.
Yeah,
Right.
you'll be ready again.
Cool. G to D, and then
We've got that extra
go,
row.
yeah, so I go there.
E.
Then
So
I'll
we've gone
go.
to E. Oops, I've changed colour.
Then I go back to G.
Yeah, G.
Now I'm going to make my repeat here.
Yeah, so you're kind of bouncing over this one that we added.
Yeah.
Yeah,
So I'm gonna
so D
repeat
again.
that. Oh, yeah, that's fine.
Yeah,
That way,
so C.
and then E, and then
E,
back to
C.
C. And then finally.
A, exactly. So that is the route that gets around. It just happens. I mean, you could go wrong, I suppose, by pushing yourself into a corner, but essentially
Yeah.
you can just whip round and it's all fine.
Yeah,
Okay?
lovely.
Right. So, little summary before you try one yourself. So we're going to start by identifying the odd vertices, because they're the problem ones that we'd get stuck at if we don't even them up. We consider all the different pairings of the odd vertices. and then we find all the different ways of doing it and pick the smallest total.
Yeah.
Then we repeat those arcs that form the smallest total, and then the new total length of the walk will be the original total where he delivers all the letters, plus obviously the roads you're going to walk along twice.
Yeah.
Most important thing that goes wrong, most important thing to be aware of that goes wrong, is the thing that we looked at. The shortest connection between G and C is not necessarily GC, and indeed the examiner is, if they've done their job well, has sneakily put another route in between G and C that you won't notice. So if the shortest connection between G and C is, for example, GAC, then when you're stating what you're going to repeat, you're not repeating GC or GAC. That's not an arc. You're repeating the arcs GA, so you're doing a repeat on that one, and A to C.
Yeah.
So you're repeating these arcs, and that's what you're getting marks for. And like you said, units.
Okay.
Okay.
Right, so let's identify the odd pathways in each vertex, right?
Yep.
So F has 2, A is even, B is odd, that has 3, and C has 3.
Yep.
D has 1, 2, 3, 4, so that's fine. E has 5, and H has 3, and that's all the odd ones.
Yep.
So now I can pair, so if I can say BC,
Yep.
and I can pair that then with EH,
Yep.
and I could have BE,
Yep.
and I could pair that then with CH,
Yep.
and finally BH,
Yep.
and pair that with EC.
Perfect.
Right, and so I need the shortest way from B to C, so I've got a 68, I've got a 50 and a 40. I don't think there's any other way, so direct, call that 68. And E to H, 150, or you've got 55 plus 110, it's still quicker. 45 plus 40 is 85, so still I think 150 direct is quickest.
Yeah.
Confirm.
Yeah.
Yeah, might need to
Yeah. I can't see anything smaller.
Cool. B to E is 50 plus, that's 95, or looking round, there's definitely nothing quicker than that.
No.
So do I have to say BDE?
Yeah, exactly. So it's BDE, because that means that when we say what we're going to, if this comes out to be the smallest, we would be repeating BD, DE, CH.
Cool.
Or maybe C something, H something, if that's not direct either.
Cool.
So yeah, you need to make a note of it.
So BDE is 95, and C to H direct is 73, there's nothing smaller than that. So that's 73.
Yep.
And B to H, 50, 45 plus 150 is 245. There's nothing quicker. Oh, hang on. 68 plus 73. 141. That's much better.
Yep.
B to H, 141. And
don't forget to write down what you were going via.
BCH.
Yeah, that's it.
And then we got E to C, which would just be the direct. Yeah, that's the direct. 85. Yeah?
E to C is direct.
Oh, sorry. Oh, I'm just looking at a straight line. EDC.
Yeah, that's
Right,
it. 85.
fantastic.
Okay, now we have them up.
Right, add them up. So 68 plus 150, 218. 73 plus 95, 168, and 85 plus 141, 226. So it is this one here.
Excellent. So now we fill in what you, in the exam you have to write this. The smallest is 168. Hence repeat what we're going to repeat.
B, BD,
Yep.
and DE,
Yep.
and also CA.
Yeah.
So is that all right written
total,
like that?
Yeah. You can just put a comma as well. I mean, essentially you're repeating BD, DE, CH.
Cool.
Your new total will be, I can't be bothered to add them up, but
Yep.
old total
Yeah.
plus
168.
kilometres, metres, miles, whatever it is. Yeah? So on your diagram now, do you want to add a repeat for BD, DE and CH?
Yeah, so
BD,
BD, we'll just add a little up like
Yep.
that.
And DE?
DE, little H as well.
And CH. And then you should, I won't write the letters down this time, but you should be able to zip round from anywhere and back to where you started. So if we use A as the post office again,
Cool.
you should be able to just zip round and end at A.
So A, F, E, A,
Don't worry about writing it down
I
this
don't
time.
write the path.
Well, you do in the exam, but for the sake of argument, just whip round it.
Okay. So,
Yep, using your extra arc. Using your extra... Oh, that probably was a
that was a
bad
bad
idea.
it can still go wrong.
Yeah.
Cool.
Yeah, you can still go wrong.
Right.
Yeah.
Okay.
Yeah, you got your extra arc there you
But
can
then I'm
use.
thinking, yeah, I've got that, and then I've got that, that.
Yep. Yay!
Done.
Sorted.
Sweet.
Yeah. No, but in the exam you do write the list of letters. As you go through each arc, you write it down in a list.
Cool.
Done. Any questions?
No, that's fantastic.
Brilliant.